Okay, I'm not an official ham radio operator until I have purchased a super cheap Pixie kit and tried to assemble it. So what I have here is the Pixie S kit, which is a little bit different because it has the remove seal after washing sticker on the buzzer as well as a LED, so you can basically hear your CW going out. So I printed off what the finished PCB should look like after it's done soldering, as well as the schematic, as well as some of the parts. So I'm trying to just make sense of some of the capacitors. We also have this little pack of resistors, and then ICs, an IC, some resistors, 7.023 crystal, which is in the amateur extra band, of which I am, but I'll probably be ending up buying some more crystals because I'm pretty slow at CW right now, and you know, who wants to miss out on the fun from talking to a technician while they're using their privileges on the 40 meter band. I think that would be pretty cool. I also have the Lexan or plexiglass top or case rather. I'm not sure if I'm going to use that or throw it in something else. So yeah, here we go. Okay, here's a little, since I'm so anal and I have to make sure I have all the parts before I start, what I did was I measured all of these resistors with my really cheap multimeter right here, and I mapped out from the schematic which resistor matches up to which resistor. Okay, I got a little lazy. Instead of taking out my LCR tester to test the capacitors, I basically put the capacitors into bunches of, it says 101, 103, 104, 471, and 473. Without calibrating or anything, I just took this capacitor, shoved it in here, turned it, pushed the button, and this says it's 98 picofarads. The value isn't very important, as important as are the values consistent amongst each group. And I found that to be relatively true. I haven't even calibrated this or anything. I haven't even read the instructions. But anyway, so I took these capacitors and I looked at the schematic. And basically I found that when it says 101, that's C3 and C7. When it says 103, those are C2, C4, C8, and C11. 104 is C1 and C10. 471 is C5 and C6. 473 is C9. And I looked at this to make all those jive basically, and it seems like it jives. So the rest of the components are relatively easy to figure out because there's only one component, or it's really easy to tell what it is. I might actually look at these two transistors because they are different. Okay, so I see 8050, and that is Q2. 8050 is Q2, and that is 9018, and yeah, so that's Q1. So that's Q1 and Q2. All the other components should be relatively easy. These electrolytic capacitors are clearly marked. I'll probably just test them on this just to make sure they're not too far off, because really the main thing of doing this is to, once we solder all of these pieces on, all of these components on, and if it doesn't work right, then the first thing we're going to ask ourselves is one component broken? And it's easier to test each individual component now before we put it on, you know, to make sure that nothing is broken. Because if it is or not working, then we'll just go into our parts bin and find an equivalent component that's working at the time of test. Who knows? We can break it while we're soldering it with my amazing soldering skills. So, you know, I'd rather know right now that all the parts worked when I tested them, because then hopefully it'll narrow down things to fix if it doesn't work. Okay, I wanted to show you how this little thing works. So I'm taking an electrolytic capacitor. I'm not even paying attention to which is negative and positive. I'm just shoving it in here. Don't do this at home, kids. I'm just shoving it in here, turning it on. That was a joke. Do this at home. You're a ham radio operator. Break things. So this is reading 11.44 microfarads. And this says that it's supposed to be 10 microfarads. So, you know, that's good enough for this being a Chinese kit and this being a $14 Chinese thing. So I'm gonna take the R8 resistor and I'm gonna put it in these little holes here and double check that everything's hunky-dory. Then I put it in, and so regardless, you just want to do whatever you want to do to get it in there, and then apply some solder, and then basically take your cutters and cut off the extra. And the reason, because the resistors, when you put this down, then the resistor is being held up by the weight and whatever of it. If instead of this R8 resistor, if we're like, we're gonna do this big honking thing, you know, wherever it goes, and it's like this, well, when you start, if you go in and put it in a resistor next, and there's nothing that's going to be holding it up, so it's going to keep falling out, you know, and you might have to bend the legs more, you know, whatever it is. So I think maybe that's a good idea, and I'll probably start with the components that are closest to the surface of the PC board and work my way out. So that probably means the resistors, the inductors, the diodes, the capacitors, the transistors, and then the rest of the components I think are a little bit thicker, and we'll see how it goes. Okay, here's how we're doing after putting in R8, R6, and R3. So that's one side. This little thing is pretty dang fun to use. Before I'm actually soldering in, I'm quadruple checking that I grabbed the correct component and that I didn't bump anything. So here we are. We're going to put in let's see, R4, and R4 is 460 ohms. And on the sheet it says it should be 470 ohms, so we'll go ahead and stick this bad boy in there and click this button, and what do we get? 464.5 ohms, and it's a resistor. Great. So you know, that is much easier than trying to read these color codes at my age, and you know, quadruple checking, is that brown, is that red, is that yellow, is that gold? Okay, we're done with all the thinnest components, which are the resistors, these resistors. And one other thing that I've tried to do was this photo. I've tried to orient the resistors so that they match the photo. It doesn't matter, but it's just one of those things that I have to do. Okay, so here's our first potential weirdness. So L1 is reading 20 microhenries, or 0.02 microhenries. L3 is 0.08, but L2, which should be 1, is reading as a resistor. So I'm wondering if this thing's resolution can't read all the way down to 1, I guess, microhenry or nanohenry. Anyway, so L2 might be a problem child. Okay, so here we are with the resistors and inductors soldered. Not bad. Alright, so at this point, all of the capacitors, resistors, and diodes, well, there's a LED and then there's the electrolytics, but all of the pretty skinny components have been installed. Not bad. Alright, so I put in the two transistors. They're both NPN transistors, and I was able to verify that they were quasi-working with that little device. Okay, so one of the things I didn't pay attention to, but it just coincidentally happened, was when you solder the IC, there is a marking on the IC that tells you which pin is pin 1, and so that determines which way the IC should be seated in here. So just coincidence, I didn't pay attention, but the IC will be seated this way, so it just turned out that I soldered it in the correct way. If I didn't, it wouldn't matter because the IC would still seat correctly in this case, but it would, you know, sort of technically be wrong because the person that would be putting in, if they didn't have a schematic, if they were putting in this IC, they wouldn't be putting it in one orientation, they'd be putting it in the other orientation. So, okay, so the electrolytic capacitors are on there, and electrolytic capacitors usually will have a white side that is marked as negative, and on the PC board it is also marked white to tell you that it's that's the negative side. Also, the negative side is the shorter lead. So if you look at this LED right here, the positive side is the longer lead and the negative side is the shorter lead. And so, for example, here where the capacitor is, it's marked D, looks like 4, and the flat, there is a plus that's marked, but then the flat side is the negative side. That's another indication that you're doing it correctly. Okay, so we're just about complete. I've soldered on almost everything except the crystal. What I want to do is I want to get a saddle for the crystal and a crystal set, test it out using the 50 ohm dummy load that was supplied. But pretty good experience with it. I folded these down rather than soldering them and cutting them. I'm not sure if I'm supposed to do that or not. I know that these two things that it's touching is not connected to anything. So some other things is negative and positive is marked. For example, on this bridge rectifier, the positive was marked. It is marked on the bridge rectifier, as well as where it should, where the positive lead should go. I didn't get that really flush, so that one's annoying me. And I don't know, everything else seemed to work, or seemed to go in pretty smoothly. So we'll tack in the crystal and see if it boots up. But that's pretty much it for the build. I don't know how long it took me, probably a couple of hours, just because I'm trying to make sure I'm 100% correct 4 times before I do anything. Alright, so assembly is complete. I finally assembled the case, and you can see that that's how I soldered the crystal. Probably not very good because those are acting as antennas, so that's awesome. Great engineering practice. But I wanted to know how much legs I can leave, so I assembled the case, and everything is together. I still have to basically test it out and see if it'll transmit into the dummy load, and then see if I can get on the air. But that's it. It was fun putting it together. It took a long time, just because I wanted to make sure I was doing it right. And this is really my first time assembling anything of value that I have purchased, even though it was like 10 bucks or something. Alright, so I've attached the dummy load 50 ohm into the antenna, and I have attached a really old Radio Shack transformer that can transform a lot of different power ranges and reverse the tip polarity and so on. I've set that to 9 volts. I think positive is the center, although it doesn't matter if positive or negative is center.